Welcome students. Good morning to all. How are you? So I am here again to continue with the previous topics of Laplace equation. Today our topic is second order partial differential equations using Laplace transforms. So this is the students' last topic of our syllabus. So till now we have discussed the basic three types of partial differential equations: heat equation, wave equation and Laplace equation. We have discussed their derivation in 2 dimension, in 1 dimensions. Then we have also discussed their solution by the method of separation of variables. Also we have discussed the Laplace equation, 2-dimensional Laplace equation as well as 3-dimensional Laplace equation in the polar coordinate form, in the cylindrical coordinate form and the spherical polar coordinate form. So these are all very important from examination point of view. Now there is a very important application of Laplace equation or the Laplace transform. Using this Laplace transform we can solve any order of partial differential equation. Right now in our syllabus we are having the solution of second order partial differential equations using Laplace transforms. So before starting this topic, we just have to remember few results so that I have written for you people. So what we are here, so students, firstly before doing the numericals of this topic, you just have to remember few results. I'll tell you what are those results which you have to keep in your mind. So let us start this topic. So the results that you have to remind, let us suppose we are having a function u which is a function of x and t. It is defined for the interval, closed interval a and b, where t is non-negative, greater than or equal to 0, and it is a function of some exponential order as t tending towards infinity and is sectionally continuous on finite interval. So basically there are some conditions on this function uxt. Firstly, uxt is a function which is defined on closed interval ab. It should be sectionally continuous on each finite interval. That is, we are having the interval a comma b. If we divide it into sub-intervals, finite or infinite, in each sub-interval, the function uxt is continuous. And second, it is some exponential order as t tending towards infinity. That is, when t tending towards infinity, the function is finite. It becomes exponential function. So, then the first result that you have to keep in your mind is L of curly u over curly t. You can see, you can read this statement where I have put my cursor over here. L stands for Laplace. So how will you read it? It is the Laplace of curly u over curly t. So the Laplace of the partial derivative of u with respect to t, you have to keep in your mind, that is s u bar x comma s minus u x 0. Then second result that you have to remember, L of curly 2u over curly t square means Laplace of curly 2u over curly t square. It is given by s square u bar xs minus s ux 0 minus utx 0. Ut means curly u over curly t, and after that you have to put t is equal to 0. So these are basically two results that you have to firstly remember before starting this topic. Okay students, then the very much next topic that you have to keep in your mind, here I am putting my cursor, Laplace of curly u over curly x. Firstly, we have discussed the Laplace of first order partial derivative, first order and as well as second order partial derivative of u with respect to t. Now the same thing I am going to discuss, the Laplace transformation of partial derivative of u, but here it is the time for x, not for t. So when we are calculating the Laplace transformation of curly u over curly x, it is equals to du bar over dx, total derivative, not here the partial derivative. And if I calculate it for the second order derivative, means Laplace of curly 2u over curly x square is d2u bar over dx square. So students, I am just giving you the tip that how to remember these two results. We are calculating here the Laplace of partial derivatives, first order as well as second order of u. Whenever I am calculating the partial derivative of u with respect to x, first as well as second, and taking its Laplace, then I will use the total derivative. When I am using partial derivative with respect to x, it is simply equal to du bar over dx, and in case of second it is d2u over dx square. But students, if we are doing the same thing, first order and second order partial derivative of u with respect to t, then you will use these two terms. Firstly, first order, it will be equal to s u bar xs minus ux0. And in case of second order, you will do like this, s square. So whatever is the order of the derivative, that will be the degree of your equation. So if it is the partial derivative of first order, here we are taking the degree of s as 1. If in the second, where I am putting my cursor, you are taking the Laplace transformation of second order partial derivative of u with respect to t, then you will use the second order degree equation of s, that is s square u bar x minus, in first part we are using ux0, in the second part you will take s ux0 minus ut ux0. Okay students, I think these things are more clear to you. They will help, all these things will help you to learn these results. Okay, now what is u bar xs? U bar xs means Laplace of uxt. So whenever I'm just using this notation, you can use on yourself. So Laplace of uxt, if you are finding the Laplace transformation of the function uxt, it is equal to u bar xs, and it is being evaluated by this formula. Here I'm putting my cursor. It is integration of 0 to infinity e to the power minus st uxt dt. Means the function whose Laplace is you are calculating, you will write firstly over here uxt and multiply it e to the power minus st dt. Okay, so curly u over curly t, where what are the symbols that I am using? Curly u over curly t is utxt, and curly u over curly x means uxxt. Okay students, so before doing the applications of the Laplace transformation for solving second order partial differential equation, you have to keep these results firstly in your mind. Okay, once again I am telling you students, L stands for Laplace. In bracket whatever we are writing means Laplace transformation of that function. Okay, so how to remember these results? Students, we are calculating over here the Laplace transformation of partial derivative of u with respect to either x or either t. So whenever doing with x, then you will use the total derivative, means Laplace of curly u over curly x means du bar over dx, and Laplace of curly 2u over curly x square is d2u bar over dx square. Okay, clear? But whenever you are calculating the Laplace transformation of curly u over curly t or curly 2u over curly t square, I am telling you students, whatever is the order of the partial derivative, that will be the degree of your equation, which you are writing on the right hand side. So it is curly u over curly t, you will write like this, s u bar xs minus ux0. When it is of second order partial derivative, you will write s square u bar xs minus s ux0 minus ut x0. So what is u bar xs? It is the Laplace transformation of uxt, that is integral 0 to infinity. Now how will you evaluate? You will write like this, Laplace of uxt. So the function whose Laplace transformation is being calculated, you will firstly write that function inside the integral and multiply it with the e to the power minus st dt. Okay, so firstly you have to keep remember all these results in your mind, then you will be able to solve the questions. So these numericals are very easy, and students, they are very important from examination point of view. Okay, so today I am just going to discuss with you only the one application or the one numerical of this topic. Onwards tomorrow I will discuss 2 to 3 numericals. Okay, so let us read the statement firstly. The question is, we have to solve curly 2u over curly x square is equals to 1 by 2 curly u over curly t, where these are the boundary conditions which are given to us, and they will help us to calculate the constants. The conditions are u0t, u5t is 0, means when x is 0, x is 5, the t is fixed, the value of u is 0, and when t is 0, ux0, x is fixed, your answer is 10 sine 4 pi x. Okay, so students, if this question come in examination, you can solve it by using the method of separation of variable also. So one option I am telling you, if you are not getting what is the method, or if you have skipped this method, there is one more option, you can solve it by the method of separation of variable that I have already discussed in my class. Okay, but if particularly it has been mentioned in the question that you have to solve it by using Laplace transformation, then you cannot use that. Even if you solved with that, you will not get the marks. Okay, so I will tell you how to solve this numerical by using the Laplace transform, but I advise you personally that please solve this question by using method of separation of variable also on yourself. Okay, so let us solve this question or this partial differential equation. It's a second order partial differential equation. You can see students here, the partial derivative of u is of order 2. Okay, so what are the steps? We are having this equation. First of all, I will take Laplace transform on both sides, that is I'll operate L on both sides. So students, I have mentioned the two results. Okay, L curly 2u over curly t square, you can read from here, L curly u over curly t. So whenever you will operate L for Laplace transform, when you will operate this, you will get, now students, you can see here on our left hand side we are having the second order partial derivative with respect to x, and whenever there is a partial order derivative with respect to x, you will use the total derivative d, and whenever there is a partial derivative of u with respect to the another variable t, you will use the equation s square. Okay, so the left hand side will reduce to, after taking the Laplace transformation, it is d2 u bar over dx square, and the right hand side will reduce to 1 by 2 is constant, so it can come out from the Laplace transformation, so it is 1 by 2 L of curly u over curly t. So what is curly u over curly t of Laplace? I have told you in the starting of this lecture, it is s u bar xs minus ux 0. Okay, so it is, let us simplify this. Here I am putting my cursor over here, you can see d2 u bar over dx square minus s by 2. These terms, they are, I am shifting here on the left hand side, minus s by 2 u bar xs is equals to minus 1 by 2 ux 0. Now it is mentioned in the numerical that ux 0 is 10 sine 4 pi x. So if it is 10 sine 4 pi x, 10 by 2 is 5, so it is minus 5 sine 4 pi x. So let us reduce this equation into the differential operator, as I have discussed so many numericals in my class. This is, it will reduce to d square minus s by 2 u bar minus 5 sine 4 pi x. Now what is d? I am using d over here as the differential operator with respect to x. So this is a non-homogeneous equation, as the right hand side is non-zero, so I will evaluate both the complementary function as well as the particular integral. So for the complementary function, students, I will firstly write its auxiliary equation. So what will be the auxiliary equation? I will just put d is equals to m and I will solve that. So it is m square minus s by 2, m square is s by 2, so m is equal to plus minus under root s by 2. So the solution will reduce to u bar is a e to the power s by 2x plus b e to the power minus s by 2x. So let us find out its particular integral, that is 1 upon d square minus s by 2 minus 5 sine 4 pi x. I told you the method that how to evaluate the particular integral. Now minus 5 is constant, it will write, you will write it on left hand side, and here it is the function sine alpha x. So if there is a function of sine alpha x, then you will put d square is equal to minus alpha square. And what is alpha over here? It is 4 pi. So 4 pi square is 16 pi square, and you will put negative sign with that, that is minus 16 pi square. So the denominator is not going to be 0. If it is 0, then it's a case of failure. Okay, so here fortunately we are not getting the case of failure. So if I put d square is minus 16 pi square, and if I simplify it, I will get, so students, what I will get, I will write the complete solution as u bar is equal to complementary function plus particular integral. So complementary function is a e to the power under root s by 2x plus b under root minus under root s by 2x plus particular integral is 10 sine 4 pi x over 32 pi square plus s. So now I will use, students, here the conditions to evaluate a and b. The first condition is u0 t is 0. I will put x is 0, e to the power 0 is 1, so I will get a plus b, sine 0 is 0, a plus b is 0, so I am getting a as minus b. Second condition is u5t is 0. So put x is equal to 5. In first equation, I will get u as 0, a e to the power 5 under root s by 2 plus b under root minus s by 2 plus 10 sine. If I am putting x as 5, 4 into 5, 20 pi over 32 pi square plus s. Now sine 20 pi will be 0, because I told you so many times that sine n pi is always 0. Okay, so I am getting over here a e to the power 5s by 2 and writing the value of b as minus a e to the power minus 5 under root s by 2 is 0. I am taking a as common, and inside I am having e to the power 5 under root s by 2 minus e to the power minus 5 under root s by 2 is 0. So here, students, please be attentive. Here I am putting this cursor. This is the product of two terms whose product is 0, so one of them will be 0. Either a is 0 or either this factor is 0. So you can see this factor is non-zero. You can simplify it, and I think I have told these things, I have explained these things many times in my class. So our possibility is a is 0. If a is 0, b is minus of a, so b is also 0. So a and b are 0. So equation 1 will be u bar is 10 sine 4 pi x over 32 pi square plus s. So what is u bar? It is Laplace of uxt, that is 10 sine 4 pi x over 32 pi square plus s. So uxt is, L will go there and it will become the Laplace L inverse of 10 sine 4 pi x over s plus 32 pi square. So 10 sine 4 pi x will come outside, and inverse Laplace L minus L to the power minus 1 means inverse Laplace transform of 1 upon s plus 32 pi square. Students, please keep remember this result. This is equal to e to the power minus 32 pi square t, means s plus this constant is over here. So you will write it is e to the power minus the constant is 32 pi square into t. So this is your final answer. So please students, go through this numerical, okay, and before starting these numericals, please keep remember these results, okay, thoroughly. Then you will be able to solve these questions. So onwards tomorrow I will discuss 2 or 3 numericals on this, its application. So students, please go through the lecture, and if you feel any kind of doubt, you are facing any kind of difficulty, you can make me call, or you can WhatsApp me, or you can ask me your query through your mail also. Thank you so much.